All right, guys, looks like I'm ready to roll. All right, again, for those just arriving, our test has been moved from Monday to Wednesday. Our goals for today are to go back over and make sure we're ready for the test. But then I'm going to move on to if I have time, to the next chapter that is going to be lost today. So back and squeeze stuff in. That will be great. Yes? All right. So you guys can see my screen. I need to come on here. What am I looking for? That's bring for all right. So in chapter 4.3, we did the fundamental counting principle again. And then after we did the fundamental counting principle, we did tree diagrams, yes. And a tree diagram right here just lists each choices at each node. And then after we did permutations. You guys remember what a permutation is? Guys remember what a permutation is? A permutation is giving the number of ways something can be ordered. Yes? How many different ways, for example, horses can finish a race? The basic concept right here is if I have 5 items and I want to know how many ways they can be ordered, the answer is going to be 5 factorial. Yes? I.e., it's an example right here. So you have 6 runners in a race. How many ways can they finish? It's going to be 6 factorial. 6 times 5 times 4 times 3 times 2 times 1. Yes? Because how many people can finish in first place? 6 people. Because there are 6 people running. How many people can finish in second place? 5, because someone's already finished in first place. Yes? How many can finish in third place? And so on down the line. And so therefore you multiply all of these together using the fundamental counting principle, and that will leave us with 6 factorial. Yes? All right. Now there's a way we can shorten that process right here. And that process right here is we're not counting everybody, we're counting a sub list. I have 10 people running a race. I only care about the people who finish in first, second, and third, because those are the people who get medals. Yes. And so I can say, how many ways can I order those 3 people? Well, how many people can finish in first place? So 10 people have an opportunity to get gold, yes? But how many people can finish in second place? Because someone has already gotten gold, yes? So only 9 people can finish in second place. How many can finish in third place? 8. And you multiply those together, 10 times 9 times 8, and that gives you the number of ways that they can be ordered. Yes? Okay. And then what we learned right here is that there is a second way of writing this answer out, not using the fundamental counting principle. And that way is by using the permutation formula. And that permutation formula, it says, we write it this way, we write 10 permute 3. Yes? 10 P3. That means I have 10 people in total. Excuse me. I have 10 people in total, and I'm going to be selecting 3 items to make a list. Question there. All right, cool. And then we did it like 500 examples. And then we moved into a combination. A combination is not when you put in something in a list or in order, but you're putting them in groups, right? If I put 3 people in a group, it doesn't matter which order I put them in. It's the same group of 3 people, right? Right? And so we call those combinations. We use combinations right here when the order makes no difference, right? If you're running a race, you don't care if you finish first, second, or third, right? Those, when the order makes a difference, are permutations. When the order makes no difference, they are combinations. The classic example is winning the lottery, right? Once you get all five numbers you win, right? It doesn't matter. You don't have to get them in the same order that they popped up in the machine. Yes. And so generally speaking, your calculating your lottery is going to be a combination. Questions there? You do have to memorize the formulas for each. This is the formula for a combination, and this is the formula for a permutation. The only difference between them is the combination has the extra R in there. You also need to be able to find these buttons on your handy dandy calculator because you are allowed to use one, so you should. All right, let's roll what I want to do today. So, you guys see that? Why does it look like it's off? Edit. Edit. I want to grab the object itself. Oh, wrong kind of edit. Where's the undo button? There we go. All right. For each of for each of the following situations, explain why the combination rule or the permutation rule should be used. Determine the number of different groups of 5 items that can be selected from 12 distinct items right here. So in this example right here, does the order in which the people are selected for the groups matter? No, it does not, correct? So therefore, this is going to be a combination. We use the combination rule since the items in the group is the only thing that's concerned. It's not the order in which they are placed in there. Then determine the number of different arrangements of 5 items that can be selected from 12 distinct items. This one is going to be a permutation because the arrangement we're considering the order in which they are arranged. Yes? Questions there? All right, let's try this one right here. Okay, you see that? A sales representative must visit how many cities? 7 cities. There are direct air connections between each city. Using the multiplication rule for counting right here, determine the number of different orders in which you can visit the cities. See if you can get the number 5,040, please, in calculator. See if you can get the answer. If you know what to do. See if you can get the answer using this right. Yeah, fine. You have the answer? Everybody got this answer? Anyone did not get this answer? The answer to this problem right here is 7 times 4 times 3 times 2 times 1, yes? Yes. And so in other words, the answer to this problem is 7. Oh, what happened here? The answer to this problem is 7 factorial. 7 times 6 times 5 times 4 times 3 times 2 times 1. Yes? Go ahead and try this for me. Try 7p7. What answer you get when you go 7p7? What answer you going 7p7? On your handy dandy calculator. What answer do you get? You go 7p7. Hmm? Hmm? Say again? You get the same answer, yes? Anybody tell me why? Why is the answer the same? Why you get 5,040 if I do 7 factorial or I do 7p7? Why do I get the same answer either way? So let me write out this way. If I ask you to find 7p2, this would mean 7 times 6, right? Two numbers, yes? Yes? Say again?
Then I'll take 7 minus 7 factorial. 0 factorial is equal to 1.
Mm-hmm. Right. So let me just go for this explain because then you're gonna hear what she says. 7p2 means I'm using two numbers. I'm a list of two numbers, right? So that's 7 times 6, right? If I had 7p5, that's gonna be 5 numbers, right? 7 times 6 times 5 times 4 times 3, right? 5 numbers, yes? 1, 2, 3, 4. So then what's 7p7? 7p7 is gonna be 7 numbers, yes? So it's gonna be all 7 of these numbers. Yes? And that's why the two things are the same answer. Yes, the same button I showed you. For example, if you want to do 7p7, hit the number 7, hit probability, and then look for NPR. Hit that and then hit 7. And then you will see and then hit enter one more time. It'll give you the same answer. So we're going by the combinations. NCR is there as well. We'll do that in a second as well. All right. Next question. All right. Go ahead and run these on your calculators. Double check, make sure you get these two answers for me, please. Sometimes it's written this way right here, P96. That simply go, this is simply 9 P6. And then C, this is going to be 10 C5. Uh-oh. It's going to be 10 C5. Again, I just want to make sure you're doing it properly in your calculator. Make sure you get these two answers for me, please. Again, if you don't know how, the point is I want to show you how, because I can't show it to you on Sunday evening, huh? Right? So I'm making you can do it. Go ahead and touch that in. But I can still follow it. I can still follow it. Where's the NPR? You know? There's no in your case, I get this. Transfer it. And once you got it, okay. So let's see the same answer gets divided by asking the factorial of R. So it's P5. Basically it's the same P and then divided by 9 factorial. So you take the answer, yeah, get the answer. Yeah. No. Yeah, so yeah, so you can do it again. You guys have factorial or something? Yeah, so try that way. If not, let's use the calculator. Anybody else? What's the difference between permutation and a combination? Permutation is trying to put things in order. Combinations of trying to find groups. Right? So for example, if I say, hey, the next person who comes in and I'm going to give them $100. The person after that, I give them 50, and then the last person, I give them 25. Right? You automatic, yeah? Somebody just won $100. Somebody just won $50. Right? Right? And so the automatic, in those cases, those are permutation. And from using, I'm rearranging stuff, finding a rearrangement. On the other hand, if I just think the next 3 people come in, you're always surprised with $50. Doesn't matter what somebody comes in. Because they just want to all 3 of them will win. But that's going to be a combination. That's the remaining groups. Yeah, yes, it's the number first, and then hit the button. All right. There are 3 nursing positions to be filled at Lilly Hospital. How many nursing positions to be filled? Position 1 is the day nurse. Position 2 is the night nurse. And position 3 is the coordinator. There are 13 qualified candidates. Determine the number of different ways the positions can be filled. There are 13 candidates. You can get an answer 17, 16. Let me see. You can get an answer 17. It is getting hot in here. Yeah, let's just explain to them earlier. It's because we're in the dead of winter, can't you tell?
No.
Well, that's the theory that they're operating on. So they have to heat, they either have either the heat on or they have AC on. So, and in what is 43, so they're lining up with the so they're operating heat. All right, did everybody get the answer? Anyone's not sure how to get this answer? All right, let's roll. So the question right here is basically it comes down to how many people are there in total? There are 13 candidates, so it's going to be 13 right here. And how many people are going to be selected? 3. 1 for the nursing coordinator, 1 for the day, and 1 for the coordinator, yes? And so it's going to be this right here. The question, is it 13P3 or is it 13C3? One of these will give us the correct answer. Which one is it? I have 2 people saying it's a permutation. Anybody else wants to jump in? Agree or disagree? It is going to be this one right here because the order matters. Okay? If you get selected for the coordinator, but you get paid more than the other 2, yes? All right, so the order matters. Go ahead, timeline 13P 3 for me, please. It should be 13 times 12 times 11, but plug this into your calculator. Questions there? Is it right? I'm crossing my fingers here. I'm pausing again. Any more questions before we move on to the next question? All right, cool. All right, so no, it's not the last one. All right, during the computer a day's special promotion, a customer purchasing a computer and printer is given a choice of 5 free software packages. There are 8 different software packages from which can be selected. How many different groups of software packages can be selected? Go ahead and see if you can get an answer. I gave you a hint. The answer is 56. See if you can get to that answer 56. And then let me know if you have a question. There are 8 software packages. You get 5 of them. So, question, if you got this computer, right? Does it matter the order in which they put the software on your computer? So therefore, it's not about arranging, correct? So therefore, it's not a combination. It's a combination. All right? Question there. And that's the kind of thing you have to see that they deliberately are trying to hide the fact of whether it is ordered or it is not. They're deliberately trying to hide that for you. So you have to read carefully to make you understand what they're happening. All right. Questions. So again, this one right here, this is going to be 8C 5, I believe it is. And what did you get in your calc? Did you guys get that answer? 8C5 is going to be 8 times 7 times 6 times 5. 1, 2, 3 times 4. Because that's 5 numbers altogether, right? 1, 2, 3, 4, 5, yes? And then you have to divide this by 5 factorial. To go from a permutation, because this top part is a permutation, right? To go from a permutation to a combination, you divide by 5, this number factorial, the number of groups you have. All right, everybody got an answer 56? Actually, these you can actually do by hand, because 5 factorial is actually 5 times 4 times 3 times 2 times 1, yes? The 5s will cancel, the 4s will cancel, the 3 and 2 make 6, correct? So it leaves us with 7 times 56. So you can actually, those you can actually do by hand. It's not too bad. The permutations are normally huge numbers, like 17 million. Those you tend to not be able to do by hand. Question. All right, last one, I think. All right. One professor grades homework randomly, choosing 5 out of 11 homework problems to grade. How many different groups of 5 problems can be chosen from the 11 problems? See if you can get this 462 number for me, please. Did everybody get his answer? Anyone not sure? Is this a permutation or is this a combination? It's a combination. And so the answer is going to be 11C5. Question there. All right, our poor friend Jerry. Jerry only did 5 problems on the assignment. What's the probability he did the exact 5 questions that were going to be graded by the professor? How did I get this answer right here? Our poor friend Jerry, he only did 5 questions. What's the chance that he got the exact 5 questions that the professor is going to grade? How did I get that in? Anybody? Knowing the answer is not going to help. Anybody? All right. They're asking us to find a probability, correct? A probability is us dividing 2 numbers. What's the total number of different ways he can get a group of 5? You can get a group of 5 assignments. What's the total number? The total number is 462, right? Out of those total number right here, how many did he actually do? How many groups of 5 questions did he do? 1, right? He did exactly 5 questions. That's 1 of the 462 questions, yeah? And so the answer is going to be 1 out of 462. Does that make sense? Okay, that sounds like a no. A lot of people looking at me. Look, the test has 11 questions, yes? The professor is going to pick 5 out of those 11 questions to grade, yes? Yes. Think of each 5 of those as one possibility. Okay? Now, assume the student only did the first 5 questions. There is a 1 out of 462 chance that those are the 5 questions the professor chose. Because that's 1 out of the 462 possible groups of 5 questions. All right? Question. Raise your hand if you want me to say that again, but this time in English. All right. Sylvia did 2 more problems. Sylvia did 7 problems right here. How many different groups of 5 problems did she complete? Let's see if we can get this answer at 21. Sylvia did a little bit more work. She did 7 out of the 11 problems. How many different groups of 5 problems did she complete? They're claiming the answer is 21. Can you get that answer at 21? Anybody wants to tell me what they think it is? Yes. Or you have a question or you an answer? All right, go ahead. Choose or permute? Permutation, we say 7 permute. 5 combination, we say 7 choose 5. 7 choose 5 is correct. 7, she did 7 questions, and out of that, we're going to be forming groups of 5. So it's going to be 7 choose 5. That'll give us an answer of 21. Question that, yes.
So anytime it says.
That's a big hint. Yes, that's a combination. Because you're making a group, you don't care what order you put the people into the group. If they say arrangements, that's a big hint. It's a permutation. All right. Anybody else? All right, then let's see if we can get the last one. What is the probability that at least one of the 5 groups she completed comprise the group selected by the professor to grade? How can we get this answer right here? 0.0455. Rounded to 1 to 4 decimal places. Can you get this answer right here? All right, everybody had opportunity. Did anybody get the answer? Is that there? And the correct answer is, again, I am finding a probability. The total number of possibilities are 462, and she did 21 of them. So 21 divided by 462 will give us the 0.04. Technically, it's 0.0454, but it rounds 0.0455. Questions there? Comments, queries, concerns? All right, so that's all I have for this section. I just want to go over some of these problems, the real life problems that you have to practice on your homework, and then hopefully that'll give us some more insight. Takes us again, like I said, because we're losing a day, because originally Monday was not a holiday. I'm going to go ahead and I'm going to move into the next chapter, and that is 5.1, Introduction to RVs. Everyone should own an RV. Introduction to random variables and probability distributions. A random variable is the outcome of a probability experiment that is numerical. A random variable is whenever we have a probability experiment where the outcomes are numerical. So if I say, what's the probability of me getting a 6 when I roll a die? That outcome is called a random variable. Okay? If I say, what's the probability that the next person who enters the room is 6 feet tall? That is a random variable. Okay? If I say, what's the probability that the next person who comes in will be wearing black? That is not a random variable because that is not a number, right? So what's happening right here is we're siphoning off all the probabilities, all those things right here that do not have numbers, so we can do math with the numbers. Yes? And so that's what we're siphoning off right here. We're saying only looking at situations where I can ask what's the probability, and the answer I'm getting back is going to be a number. All right? Questions there? All right. So we're not going to ask what's the probability that this person is going to win the next show. I don't know if they're having a show over there this afternoon. We're not asking the probability who's going to win that show, right? That's not asking. We might ask what's the probability that 500 people show up, right? Or what's the probability that 2,000 people show up, right? Those are random variables. All right. Random variables are not like algebra, blah, 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 blah. And what they're trying to say is that the sample space, the outcomes are only numerical in terms. That's all they're trying to say when we're talking about a random variable. All right? The outcomes are numbers. Questions? Generally speaking, a random variable, we use a capital letter to define a random variable. In this case, we're using the capital letter X, and then they give the description of X right here. X is the top number, the number on the top face of the dice. Or X is the number of people who went to see the show on the set. Or X is the scores on the test number 3. Or X is the number of days students spend in a classroom, right? A number of hours you spent doing something. That's what your random variables are. Questions there? There are two kinds of random variables. There are ones that are called discrete random variables and discrete random variables. The numbers are whole numbers. They're numbers that can be written down always. Example of a discrete random variables, the score when you roll a die, the number of children a family has, or number of siblings a person has, right? Or the number of shoes you have in your closet. The key thing right here is that the answer is not a decimal. The answer can never be a decimal. Okay, when we say discrete, that's what we mean. The answer is going to be a whole number. Could be negative as well. I should say integer, but the answer has to be nice and neat, right? Often these are how many questions. Yes? Question there. A continuous random variable, on the other hand, is a value that can take on any number on an interval. If I ask you right here, how tall is someone? Well, that person might be 6 feet tall, or they might be 6'1", or they might be 6'1.5", or they might be 6'1.285", or they might be 6'1.285372215, right? It's not a discrete number. It literally is a number that can appear anywhere on an interval. The heights, amount of electricity used, time, how many hours have gone by, how many minutes, how many seconds have gone by, right? You can take your 7.837265837 seconds to do something, right? Those will be our continuous random variable. Continuous. Questions there on the two? Discrete versus continuous. Continuous comes from the idea of a continuum or an interval. I can get any score between your height, can be any value between 0 and 10 feet. Does anyone have been 10 feet tall? Maybe. I guess I should ask the internet people, yes? Back in the day, that used to be the big thing. People just used to discuss crazy stuff like that. Because but now you can just go on the internet and take like 10 seconds and you can tell, yeah, there's been people who've been 10 feet tall. It's really sad. A probability distribution for a discrete random variable simply gives you the probabilities for each outcome. Because of that, remember, a probability is always between 0 and 1. You have this one rule right here. The second rule right here is that when you add up all the probabilities, they must sum to 1. A probability distribution for a discrete random variable assigns a probability for each possible value. Okay? The chance of 500 people showing up over there, 25%. The chance of 600 people showing up, 30%. That's going to be a probability distribution. Okay? There has this one relating factor right here that if you add up each of the individual probabilities, they must give you 1. Questions there? Let's look at an example. Is this right here a probability distribution? First things first, the numbers up here. First things first, the numbers up here are your outcomes. There should be an X right here. And then there should be the probability of X down here, right? So in this first outcome right here, the only numbers that can happen are 1, 2, 3, and 4. This might be the number of shoes you have in your closet. Let's assume you're all struggling artists. So you only have up to 4 shoes in your closet, right? And so the probability I select somebody at random, there's a 25% chance that they have 1 shoe, and so forth and so on. The question though is this accurate? Is this an actual probability distribution? And the answer is, this is a problem. A probability cannot be negative, yes? All probabilities must be between 0 and 1. 0% means it will never happen. 100% means it's guaranteed to happen, yes? And so because of this, this is not a probability distribution. Questions there? How about this one right here? Is this a probability distribution? When you add up all of these numbers, do they add to 1? They do. And so this is a probability distribution. Questions there? The idea behind it adding up to 1 right here is that these are the only possible items. If I added a number 2 on here, the probability is going to be 0. It can't happen because I have already considered all the possibilities. If they add up to 100%, one of these things and only one of these things can happen. Everything else is 0%. All right? That's the idea behind it must add up to 1. Last one right here. Is this a probability distribution? It's a little tricky. Is this a probability distribution? When you add up the 4 numbers, how much do you get? You get 0.99, and so therefore this is not a probability distribution. Question, yes.
So like, if you're, I'm sorry, I thought there was one question, but like, why can't you do round?
Because what's happening is what this is telling us is that there is an outcome that's missing. For example, they didn't remember to write down 0. What's the probability that the person gets 0? Let's say this is the number of nanomachines you have working for you. What's the probability the person gets 0 nanomachines? That's missing. And that's going to be 0.01, right? So in other words, this is incomplete. And that's why it's not a distribution. A distribution is supposed to assign or tell you the probability for each item. This is saying the probability of getting 100 nanomachines is 0.56, right? What we're saying is because it's this, it's not doing a proper job. It's not assigning the probability to every outcome. All right? Anybody else? Similarly, if this was, for example, say 90.92, this will be over 100, right? Over 100%, right? Actually, 9 and 6 is 9 and 5 is 14. That's 1.5 something, somewhere around there, right? This is again impossible because if there is a 92% chance of this happening, you can't also have a 56% chance of this happening. Yes? And so that does not make sense. That's why it must always add up to exactly 1. Anybody else? All right, cool. All right, example. Let's using probabilities distributions. 4 patients have made appointments to have their blood pressure checked at a clinic. Let X be the number of patients that have high blood pressure. The probability distribution of X is, so I should have X up here. I should have the P of X down here. So this means, this 4 here means all 4 people have high blood pressure. This 1 here means that out of the 4 people, 1 of them have high blood pressure. Yes? You can verify if you add these up, you get the answer of 100, 1, sorry. And so then they can ask the question right here. Well, and so this information can also be given as a frequency histogram. And 0 right here goes up to 0.23, 1 right here goes up to 0.14, and so forth and so on. These 2 things are the same. One is just a picture, the other is just numbers. Questions there? This is the preferred method, generally speaking, but this right here has implications for continuous, so we teach you about these as well. This also shows you that clearly it's very unlikely that all 4 people have high blood pressure. Yes? The most likely case is that 1 person or maybe 2 people will have high blood pressure out of the 4. All right? And so just by looking at the picture, you can kind of see what's going on with the data. Questions? All right, cool. Find the probability of 2 or 3. Or in mathematics, in probability, is it to add or multiply? Our ability is to add. In this process right here, is it possible for both 2 and 3 people to have high blood pressure on a single day? Is it possible out of the 4 people, 2 of them exactly have high blood pressure and 3 of them exactly have high blood pressure? Is that possible? No, it's not. And so these are mutually exclusive events. And so therefore the probability of PO2 is simply going to be the probability of 2 plus the probability of 3, or means to multiply. And so you just have to add them together. There is a 35% chance that either 2 or 3 out of the 4 people will have high blood pressure. Questions there? It wasn't me. I'm just happy it wasn't me. Questions there? Huh? Cool. Let's try again. We have the same thing right here. What's the probability of 2 or more? What's the probability of 2 or more people having high blood pressure? Go ahead and see if you can figure that one out for me. Please give me an answer. What's the probability of 2 or more people have high blood pressure? The answer would be this plus this plus this will give us our answer of 2 or more people having high blood pressure. Yes? So that's going to be add them up. Thank you. And you are indeed right, 0.36. Questions there? There is also another way to solve this problem right here. The other way to solve this problem right here would be to, let's switch to blue right here, or green. It will be to add these two numbers up and then subtract them from 1. 1 minus 0.23 minus 0.41 will give me the same answer, 0.36. Why does this work? Why does this work? Because I said so? Because the total is 100%, the total is 1. Yes, remember, this is a probability distribution. When you add up all the numbers, it's 1, correct? So if I take the total of 1 and I remove these two, what's going to be left over? 2, 3, and 4 is going to be left over if I remove 0 and 1 from the total, yes? And so therefore, this will work as well. Questions there? All right, cool. What's the probability of at least 1? It's going to be this plus this plus this plus this, yes? Or 1 minus the 2.3, yes? Or just cut this out and that will give me my same answer, yes? Questions there? And so at least 1 means more and more. And so the easiest way is to use the rule of complements, i.e. take the whole and just remove this piece. I.e. just take the whole, which is 1, and remove this piece, and it will leave you with everything else. Or you could add them up. You could add them up 0.4 plus 0.2, 7 plus 0.08 plus 0.1. You can add them up. You get the same answer, 0.77. Questions there? Comments, queries, concerns? All right. I think we're just about there. Yeah, we'll stop here. All right, so again, a disclaimer, chapter 5 is not on the test. Yes, but just don't forget all about it, right? Because literally the next time we'll continue to be next week Friday. Then we're going to be continuing this stuff, yeah? Because Monday's a holiday, we have the test on Wednesday. So it's going to take us a while to get back to this, all right? Let me take attendance.